class 12th, subject physics, 6th chapter, superposition of waves. Superposition of waves. From this chapter, let us see bits, that is, what are the bits and how these bits are formed. The phenomenon of bits is based on the principle of superposition of waves. That means the phenomenon of bits takes place due to the principle of superposition of waves. Now actually how the bits are formed. So for that, when two sound waves having same amplitude but slightly different frequencies traveling in the same direction superimpose with each other, then the intensity of sound waves varies periodically with time, and this phenomenon is called as the formation of bits. So when two sound waves having same amplitude but slightly different frequencies traveling in the same direction superimpose with each other, then the intensity of sound waves varies periodically with time. This phenomenon is called as formation of bits. That means in case of formation of bits, sometimes the intensity of sound will be maximum and sometimes the intensity of sound will be minimum. And the sound of maximum intensity is called as waxing. The sound of maximum intensity is called as waxing, and the sound of minimum intensity is called as waning. Sound of minimum intensity is called as waning. Now, one waxing and successive waning together forms one bit. So, one waxing and the successive waning together forms one bit. The number of bits heard per second, the number of bits heard per second is called as bit frequency. So this will be regarding the formation of bits, and now let us see the analytical method to determine bit frequency. Now how analytically the bit frequency will be determined. So for that purpose, let us consider the two sound waves. So consider two sound waves having same amplitude A and slightly different frequencies N1 and N2, which are meeting in phase at any point x. So the amplitude of both these waves is the same, that is equal to A, and their frequencies are slightly different as N1 and N2. So when there is superposition between these two sound waves, at that time the displacement of waves are given as. So before superposition, the individual waves will be given as, that is displacement of that wave y1 will be equal to a sin 2 pi n1 t, y1 is equal to a sin 2 pi n1 t, and second sound wave is having its displacement as y2 is equal to a sin 2 pi n2 t, y2 equal to a sin 2 pi n2 t. So these are the two displacements of the two sound waves before superposition of the two waves. Now as soon as the superposition between these two waves, that is mixing of two waves, takes place, at that time the resultant displacement will be equal to factor sum of the displacements due to these two waves having displacements y1 and y2, and therefore resultant displacement y will be equal to y1 plus y2. Y is equal to y1 plus y2. Now putting the values of y1 and y2, we will get y equal to a sin 2 pi n1 t, y equal to a sin 2 pi n1 t plus a sin 2 pi n2 t plus a sin 2 pi n2 t. From these two terms, only a is taken common, and therefore we can write y equal to a into sin 2 pi n1 t plus sin 2 pi n2 t. So taking common a, we will get sin 2 pi n1 t plus sin 2 pi n2 t. Now this will be treated as sin C and this will be treated as sin D, and therefore by using the formula sin C plus sin D, sin C plus sin D equal to 2 sin C plus D by 2 into cos C minus D by 2. 2 sin C plus D by 2 into cos C minus D by 2. By using this formula, we will get y equal to 2a into sin 2 pi n1 plus n2 upon 2 into t sin 2 pi n1 plus n2 upon 2 into t into cos 2 pi n1 minus n2 upon 2 into t cos 2 pi n1 minus n2 upon 2 into t. From this 2 pi will be same for both these two terms, therefore it will be taken as common. Similarly t is also same here, therefore it will be taken common, and only C plus D by 2 means it will be n1 plus n2 by 2 and C minus D for that term n1 minus n2 upon 2. And therefore after this, if you consider this substitution, that is let n1 plus n2 upon 2 equal to n1 plus n2 upon 2 equal to n, this will represent mean of or the average value of n1 and n2, let it be equal to n. And second 2a cos 2 pi n1 minus n2 upon 2 into t, for that 2a cos 2 pi n1 minus n2 upon 2 into t is equal to a, where this a will represent the amplitude of the resultant wave. Now putting this substitution, we will get y equal to a sin 2 pi nt, y equal to a sin 2 pi nt, where a is the amplitude of the resultant wave and n is the frequency of the resultant wave. Now this equation is the equation of progressive wave. This equation is similar to that of the equations of y1 and y2 in the same form, and therefore as y1 and y2 are the displacements for two progressive waves, similarly this resultant wave y is equal to a sin 2 pi nt will also represent the equation of the progressive wave. Now we know that in case of sound, the intensity of sound is directly proportional to square of amplitude. We know that the intensity of sound is proportional to square of amplitude, and therefore if the intensity is maximum, amplitude will be maximum. If the intensity is minimum, amplitude will be minimum. And therefore let us find the conditions for maximum amplitude and minimum amplitude. So let us see first one, that is for maximum amplitude of that resultant wave. For maximum amplitude, so for maximum amplitude, that is for waxing. So as amplitude is maximum, that is A is equal to maximum, therefore from this relation this term will be having its maximum value, and its maximum value will be equal to plus or minus 2a, plus minus 2a, because cos of this angle may be either plus 1 or minus 1, and if it is plus 1 or minus 1, therefore the maximum value of this a will be equal to plus or minus 2a, and therefore for waxing or maximum amplitude a is equal to plus minus 2a, or we can write 2a cos 2 pi into n1 minus n2 upon 2 into t will be equal to plus or minus 2a, is equal to plus minus 2a. So in this point a is equal to plus or minus 2a, and therefore 2a cos 2 pi into n1 minus n2 upon 2 into t must be equal to plus or minus 2a. Now if this term is equal to plus or minus 2a, it will be plus or minus 2a only when cos of this angle, that is cos 2 pi n1 minus n2 upon 2 into t, is equal to plus or minus 1, and therefore we can write, therefore cos 2 pi n1 minus n2 upon 2 into t must be equal to plus or minus 1. Now if cos of this angle is plus or minus 1, therefore the values of that angle 2 pi into n1 minus n2 upon 2 into t, for this angle the values will be 0, pi, 2 pi, 3 pi and so on, because for these angles cos of that angles will be equal to either plus 1 or minus 1, and therefore we can write 2 pi into n1 minus n2 upon 2 into t. So for this angle the values are 0, pi, 2 pi, 3 pi and so on. Then therefore we can write, from this we can write t is equal to, that t will be equal to 0, because first angle is equal to 0. If we put value of t equal to 0, then this total term will become equal to 0. Now the second angle is pi, so here there is pi, these two will get cancelled and only n1 minus n2 into t will be left. So if we put the value of t here, 1 upon n1 minus n2, 1 upon n1 minus n2, then it will get cancelled with this and we will get value pi, that is the second value of angle. Similarly, next angle is 2 pi. So for this 2 pi, if we put the value of this t equal to 2 upon n1 minus n2, if it is 2 upon n1 minus n2, then these two will get cancelled and this 2 into pi we will get 2 pi. So in this way the time intervals at which the intensity of sound will be maximum, these intervals are t equal to 0, 1 upon n1 minus n2, 2 upon n1 minus n2, 3 upon n1 minus n2 and so on. That means we can say that for these values of t, that is for these time intervals at 0, 1 upon n1 minus n2, 2 upon n1 minus n2 and so on, there will be formation of the waxing. And therefore if we find out the difference between the successive time intervals, the distance that is time interval between two successive time intervals, then here we will get 1 upon n1 minus n2 minus 0, that is equal to 1 upon n1 minus n2. Similarly 2 upon n1 minus n2 minus 1 upon n1 minus n2, that is 1 upon n1 minus n2. So for each and every successive time intervals, the difference between the time intervals will be equal to 1 upon n1 minus n2, and therefore this will give rise to the period of bits. That will be the period of bits, and therefore we can write period of bits t equal to 1 upon n1 minus n2. Now we know that frequency is the reciprocal of period, and therefore if 1 upon n1 minus n2 is the period of bits, therefore frequency of bits will be equal to n1 minus n2. Frequency of bits equal to n1 minus n2. So this will be the expression for period and the frequency if we consider the maximum amplitude of the sound, that is during the waxing. Now let us consider the second case for minimum amplitude. For minimum amplitude, that is waning. For minimum amplitude, that is waning. So for this waning, the value of this A must be equal to 0. So its minimum value will be equal to 0, and therefore we can say that for minimum amplitude A must be equal to 0, or 2a cos 2 pi n1 minus n2 upon 2 into t must be equal to 0. So 2a into cos 2 pi into n1 minus n2 upon 2 into t must be equal to 0. Now 2a will be never 0. 2a is not equal to 0, and therefore cos of this angle must be equal to 0, so that this product will be equal to 0. And therefore we can write cos 2 pi n1 minus n2 upon 2 into t, it will be equal to 0. So 2a is finite value. If you multiply this 2a by 0, then we will get answer as 0, and therefore cos 2 pi into n1 minus n2 upon 2 into t equal to 0. Or if cos of this angle is equal to 0, therefore that angle will be having its values, that is 2 pi into n1 minus n2 upon 2 into t. That angle must be having its values pi by 2, 3 pi by 2, 5 pi by 2 and so on, because for these angles the cos of these angles is equal to 0, and therefore again we can find the values of t here. So here first value is pi by 2, so here it is pi by 2. Now we will have to cancel this 2 into n1 minus n2 by putting the value of t. So in place of t, if we put the value as 1 upon 2 into n1 minus n2, 1 upon 2 into n1 minus n2, then this 2 into n1 minus n2 will get cancelled and we will get pi by 2. Similarly here for this 3 pi by 2, if we put the value 3 upon 2 into n1 minus n2, 3 upon 2 into n1 minus n2, then we will get 3 pi by 2 and so on. And therefore the time intervals t will be equal to having its values 1 upon 2 into n1 minus n2, 1 upon 2 into n1 minus n2, 3 upon 2 into n1 minus n2, 3 upon 2 into n1 minus n2, 5 upon 2 into n1 minus n2, 5 upon 2 into n1 minus n2 and so on. So these are the time intervals at which the amplitude is minimum, that is vanning will take place. And again the time interval between two successive vannings will give rise to period of bits, and therefore here period of bits will be equal to 3 upon 2 into n1 minus n2 minus 1 upon 2 into n1 minus n2. That will be equal to 1 upon n1 minus n2. Similarly 5 upon 2 into n1 minus n2 minus 3 upon 2 into n1 minus n2 will be again equal to 1 upon n1 minus n2. And hence if period of bits equal to 1 upon n1 minus n2, therefore frequency of bits will be equal to n1 minus n2, that is reciprocal of period. So frequency of bits equal to n1 minus n2. So if you compare the 2 points, that is for waxing as well as vanning, the period and frequency is the same. So for both waxing as well as vanning, the period equal to 1 upon n1 minus n2 and frequency of bits equal to n1 minus n2, n1 minus n2. And now from this we can conclude that the waxing and vanning are alternately situated. Waxing and vanning are alternately situated. And now let us see the next point, that is applications of bits. So bits are having various applications. First is for tuning of musical instruments. For tuning of musical instruments, that is for matching the frequencies of the musical instruments, the formation of bits will be used. So formation of bits is useful for tuning of the musical instruments, that is for matching the frequencies of different musical instruments. This formation of bits will be used. Second use is to determine the speed of aeroplane. So the speed of aeroplane can be determined by using Doppler effect, and for that purpose the bits will be used. Third use is in speed guns. That means when any vehicle is fast moving, at that time to determine the speed of that fast moving vehicle, the traffic police uses the speed guns. Then fourth use is in ultrasonography and echocardiogram. In ultrasonography, in case of ultrasonography and echocardiogram, that is for checkup of the patients, these techniques will use the formation of bits. Similarly, Fifth use is to determine the unknown frequency of the sound notes. So the unknown frequency of the sound notes can be determined with the help of the formation of bits. So these are some of the applications of the bits.